every day a new video. For the new ones, this is code draw, and as usual, we're gonna do some lead code problems. So today we're gonna practice some heap. It's a data structure that is similar to a list, but the time complexity of it's much lower than a list. So as usual, we're gonna do some little problems like two, and oh, I forgot to put the theme of the this video because I was already busy doing something else. So welcome everyone. Bring your tea, bring anything you can drink, and chill with me and code with me, of course. But for that, don't follow us on GitHub. This is my GitHub account. You can find my social media links in the YouTube bio. So this is my LinkedIn, my GitHub, my Instagram, and recently we created a server, the Discord, to connect better with you. So feel free to join it everywhere, anytime you want. And without further ado, let's go to the lead code problems. So those are two Geek for Geeks articles to help us through the heap thing. So let's bring the illustrator here and let's go to the lead code problems. Mm-hmm, 71. This is the okay, so let's put it here and this is it. So I already did this lead code problem, but in a while I really forget it. I did it in Java, I think. I didn't really do it in Python, so I think it's a good warm up for the lead code heap thing. So without further ado, let's go. Oh no, this is the thumbnail thing. Okay, so this is it. Okay, so those are the problems we did yesterday. Let's bring our this new artboard. Okay, so we're ready. So here we have the kth largest element in an array. So given a integer array nums and an integer k, return the kth largest element in the array. Note that the kth largest element is the sort order, not the kth distinct element. So can you solve it without sorting? Okay, so we're not gonna use sorting. We're not gonna use list dot sort. So there is our nums and this is k. So we're gonna find the the first two largest element, or the second. See the second largest element, which is 5. We have 6, the first largest element, and 5 is the second. And here example. So okay, so to give a better idea about the heap, so the heap we can visualize it as a tree. So this we have a max heap and min heap. So the max heap, the root of it is the max element. So I think this is not the hard. So we're gonna simply do the heapify thing, and we're gonna, so when we make the heapify thing, we're gonna convert the list into a heap, and then I think we're gonna make a for loop. So we make a for loop in nums, and then if main leap. We're only gonna push the largest element than k. So hey, welcome chat. So how do we just this? Okay, so I think this is better. Okay, this is better. Okay, so let's start with just the import heap q and then heap q dot heapify. Okay, so we're gonna start with the input. Excuse my voice because I'm a little bit sick, so import heap q and then we're gonna heapify. So simply gonna do some operation to understand better. So heap q dot heapify nums, and then simply I'm gonna print nums to see what it looks like. Okay, so 1 2 3 4 1 2 3 5 6 and 4. Okay, so we're gonna simply so why is it 1 2 3 2 3 4 5 5 6? Okay, so this is a min heap, it's not a max heap, I think. So we're not gonna heapify it. Hey, heads of man. Hey, thank you, man. Welcome stream, man. So I think we're gonna simply I'm gonna use the push, I think. Okay, so use the push element into heap. So heapify heap q. Oh, so we're gonna create a new list, and then we're gonna make a max. Okay, so let's start with creating a list. Let's call it L. We're gonna simply push into it the max elements and then print the last one. So heap q dot push with this thing. So I'm gonna make heap dot q. I'm gonna make it a heap. So heap q heapify, and then for num in nums for num in nums you have to make max closest element. Hey, welcome chat. So for nums in nums hey, welcome. So what do we I think we're gonna need this. So for nums and nums, if I think we will have a condition here, and then we're simply gonna push. Let's push into it. So heap push L and num, I think. okay. uh, what is okay? So we're gonna push 4 and then we're gonna push 6. But why it is like this? Hey chat, how are you? So it is like this. Okay, so I'm simply gonna make forums and none. When we're gonna stop? We're gonna stop in K. Okay. No. So what did the heapify is making? So 1 and then 2 3 and then 5 6 and then 4. Heap push. So this the heap. So it was 5 7 9 1 3. So 1 3 9 7 and 5. 9 7 and 5. Hmm. High recipe and mine. No. Hey, I'm also doing lead code to tell me what is best. Hit and try until you solve problem or worse some tutorial. I have a really good tutorial that I have been advising everyone to watch it, which is the 15 lead code patterns. So don't just solve lead code problem randomly. Just follow this patterns. He's gonna give you the most popular patterns. So focus on them and then go to the lead code 75. This is the first 75 problem that are divided into or categorized into patterns. So this array pattern and then 2 pointers and then we're gonna like use every data structure. So you'll learn the structure doing this lead code. Don't just do it randomly. So I was gonna do it. So competence and smallest element is 1. Okay, so he's gonna pop the smallest. Oh. Oh, okay, so I want to see. I want to see when I pop. Is he gonna give me the? Hey, no problem, man. Welcome, man. Hey, welcome stream, man. Here. So I think I'm gonna push L nums and then coder 0 0. You're welcome. So so I think we're gonna pop here or push, and then if when we go, okay, I'm gonna print this to see what's the content of it. AP5, okay. So we don't need that anymore. Okay, so I have 1 3 2 5 6 4. Oh man. really tough. Uh, do we have to change the VK or Flynn mean heap? So he's gonna push one, and then he's gonna push three. Then he's gonna push two. Oh, 0, 1, 2, 1, 2, and then he's gonna pop min heap. I want to see min heap. I want to see when if len of the L is greater than K, so what are we gonna do? We're gonna simply pop it. No, not that, but yeah, we're gonna simply pop it. So we're gonna heap pop L. Okay, so want to now see the L. Okay, so 5, 6. Okay, so good. So this is it, and this is it. Okay, so simply gonna print the L of or return. After all that, we're gonna return the L of 0. Because he's gonna in the first try the first try is gonna push and nums, and then he's gonna push he's gonna push the 6, and then he's gonna push the 5, and then he's gonna stop. So we're gonna pop it, pop the element after it, and then we're gonna return the 0, which is the first element. I think okay, so it is correct actually. Okay, yeah, the runtime is not yeah, the runtime is not the bad actually. Hey, we did this in like 70 minutes. Oh, that's good. It's actually so good. Hey chat, how are you? Things fine. Okay, so okay, so now we'll go to the next one, which is the smallest number in an infinite set. Okay. So I have a set which contains all positive integer 1, 2, 3, 5, and implement the smallest infinite sets class. The smallest infinite set initialize a small infinite set object to contain all positive integer. Okay. Okay, so this is a set, I think. And int pop smallest is gonna remove or return the smallest integer contained in the infinite set. Okay. So void add back int num adds a positive integer num back into the infinite set if it's not already in the infinite set. Okay, so the input if is the set, the add back, the pop smallest. Okay. I'm really not understanding this. So small infinite set equal new small infinite set. Add back. We added 2. Is already in the set. No change. Okay. Pop list. So gonna on. Since one is most number and remove it from the set. Okay. So initialize this most number set object to contain all positive integer. Okay, so those are positives. I think I'm getting it. So now here, small infinite set, small new small. Okay, so this is the small infinite set. Add back two. So we're gonna add two. Two is already in the set, so no changes made. Oh, it's already in the set. And then smallest infinite set dot pops smallest. Return one says okay, so infinite set pop small return two and then return three. Okay. Oh, so now no change and then return two. Oh, and then what? Hmm. Pop smallest and then add back one. One is add back to the set. Small infinite set. Return one says one. Okay, I'm really not understanding the input and the output, but I think I'm understanding the function itself. Hey bro, I'm working on some little problem. To one join. Uh, yeah, of course, of course. Let's jump on Discord. I mean, I just have to work on this problem because today I have a assignment like project. So it would be nice if we don't if we don't last last if we don't take much time on these problems. So I'm in the Discord. Yo, chat. So we are on Discord. If you want, if you ever want to join, you're free. The Discord link is in the in the YouTube description, or I think you can do it by typing just Discord like this. Hey, where is the Nightbot?
Hey, hey,
Hey, Amin, how are you?
I'm fine, I'm fine. Yes, I get some assignments to do.
What?
You have some assignment to do?
No, just today I have a project to present, so I'm just gonna do a little problem and then I'm gonna prepare for it.
You're going to stream it or not? The project.
Uh, well, I think not. I'm gonna stream it tomorrow after the presentation. I think that's gonna be better.
Okay, okay. And you have to work also on my website. We can get some one or two problems.
Uh, do you want to work on this heap problem?
Okay, okay. It's the smallest number in infinite set. Okay, okay. I'm looking for it.
I think it's not gonna take us so much, but it's good. It's good actually. about 24 minutes. Okay, so I think the whole idea here we have, first of all, we have
We
to
need to do.
what? We just have to initialize the variable. So I think I'm gonna initialize the heap and a set, which is the set for the infinite set things, and then we're gonna make the just the current an integer, which is self.current to put later on it the minimum the minimum number. Oh, did you read the description, or do I have to wait?
Yeah, I'm reading it. I'm reading it.
Okay, okay.
So we have to initialize the smallest set contain output of integers. Then we have a method which is pop smallest root and return the smallest integer contained in the infinite set. Void add back add equal to return them back into the unit set if it's not already. Here, if we want like a O of one like a retrieval of the smallest, I think as you said a min heap is the answer.
Yeah.
Uh, yeah, but I don't see what is the constraints. I think it's obvious, no? Mm, void add back adds a positive integer back into the infinite set. Okay, okay.
Like
Okay, I don't know why they call it the infinite set. Like that's okay. It's
yeah, it's not like infinite or something. That's just calling it.
yeah, that's weird. Okay,
Is there like a
which is not smallest. Which contain all positive integers, root and return the smallest. Okay,
let's
contained
import
in the infinite set.
import heap q. Is there like set?
So if it's called a set, that means that um, it cannot contain two
Duplicated
two of
number.
the same, yeah, duplicated numbers. Yeah. Let me, for example, smallest add back.
I think here heap dot push self heap and no, I think that's correct. After that, how am I gonna do it? Well, I think
Okay,
it's a basic approach. We're gonna define a heap, then a set, then the a current. So and and I think that, yeah. Let's now focus on the other functions. Like the pops mode, we're just simply gonna make pop and then remove it from the set. I think.
okay.
Uh,
Mm,
so we're gonna make simply
I think I'm not educated, but
edge case.
yeah, it started off with
Oh,
function.
it has to be. So the pub there is a edge case, but in the add back, is
Yeah,
there
in
also
the
edge
edge
case?
case, like if we pop an empty,
Yeah. So
yeah,
so here I think we're gonna make if self dot heap. If self dot heap. Do you want me to share the screen? I'm gonna share it. Okay.
yeah, share the screen. I'm gonna share my screen also.
Okay. So this is it. Mm-hmm. Okay. So I think we're good.
Okay, okay,
And
yeah, I'm seeing your screen.
and here
Okay,
we're
so
gonna.
what's current?
So this is it.
The current.
Well, I think the current we're gonna need it in the smallest to find which is the smallest one.
Um,
And here we're gonna remove the S, I think.
okay, yeah. No defense. Okay, so I think we only need to keep track of the top element of the heap, which is the lowest element, the smallest element.
Yeah, so we're gonna make it in the current.
Yeah, the current, well, which is
So,
one.
okay, so I think here we're gonna make else, I think.
Uh, Pop smallest. Uh, yeah, recurrent. The
Recurrent.
self. No, no, I don't think. Look for the. Why did you have a condition on if self dot heap?
To not to pop. So we have to check if it's not empty.
Um, no, in fact, initially the set contains all the numbers, so it cannot be empty.
No, not the set, the heap.
Oh, ah, what's the difference between the heap and the set in your code?
The heap is gonna have the all number, and even if it's like duplicated, and the set we're gonna make just numbers and not duplicated.
Uh,
I see.
I don't think that's necessary.
The set.
I think like a simple heap actually would be sufficient.
Okay, so without set. Okay. I'm just gonna make it in comment, but I think okay. So let's go by your idea, and then we're gonna modify if it's not correct.
So for the pop smallest, we would do actually
I think
to
we're gonna return here S, the smallest.
pop heap. No,
But if we have a empty heap and we're gonna use the pop smallest, then What we're gonna do?
It will be add back at the positive integer back to the infinite set. Yeah, that's weird. Yeah, we have to think. Uh, it's a bit tricky also because the idea of the infinite set is kind of misleading.
Yeah. Mm.
Okay, okay, okay. Clever.
Mm.
Going through the examples to see how the set work.
Yeah.
Okay,
Okay.
let's go.
Return best.
What we do this
Uh,
return what?
have to add like.
Remove it from the set.
Oh, think here. If the heap is empty and we have to pop smallest, we're simply gonna make the value of the s here. We're gonna make it current, and then we add current a number like plus one or yeah plus one, and then we return the smallest either way.
Okay, okay, okay.
Okay, so I think here I'm gonna make s equal current and self dot equal one, and then return s. I think this is good for the pop.
Ordered set.
Uh, and for the set, like if you focus with the example,
Okay.
um, when he uh, when he pops smallest, like he say return and then remove it from the set.
Ah,
Does he mean he doesn't mean the heap?
no, I don't think. No, the set is like a general term
A list.
like the object set, like the smallest infinite set, and another smallest is gonna return gonna return actually three, not two, which is mean that it is like it is not existing in this set anymore. But it depends on how you do it. Like you don't illustrate on whether like two actually exist inside your heap or set.
No, okay.
It should like it shouldn't be existing in the smallest infinite set, like in the object. It means that it cannot be popped or okay.
No, like I want to. I'm just simply gonna run my code to see. Okay, so heap q. Oh, okay. No attribute heap push. Oh, okay. So oh, okay. So uh,
Like an infinite heap.
hmm.
Okay. I think we should keep track of the popped elements.
Yeah, which is S.
No, no. Imagine like if we had like three popped elements. Where would you store them?
Do we have to store?
Yeah, because if like you added like one of them,
Okay, so let's add it to the set, to a list, or
yeah,
like use a list, and then when
one
not really getting
and
it.
roughly.
Okay, this, this. Or like this add. No, I'm not gonna add. Okay, so I have to add it here also. So, self dot add self dot set dot add. No. Okay. Uh, Yeah.
Okay. Okay. Set of popped elements. It's already top. I don't think we need to store it for now. Okay, to pop the. Actually, okay, I think I got it. So, to pop the smallest, actually, we need to check if the popped element, if it's not like if it's empty, it means like we didn't pop any element, so the popped element would automatically be one.
Yeah.
Yeah.
So we're gonna add it to the set,
Uh, where?
or like a list, or like something we're gonna store in it.
To store the popped elements.
Yeah.
Yeah, yeah, yeah. Like a set, yeah.
Yeah. Okay. So
If not,
current, and
add it.
we have to add the current.
Okay, so if it's empty, like return one. Like, but now, uh, but in the case if it's not empty. Ah, okay. I think I got it. Actually, if it's not empty, I think we would pop the kth smallest element.
The kth.
Yeah. For example,
What's the k for?
if the length of popped elements, like it's if it's equal to k, it means like we popped the kth smallest element. It means like we popped, for example, 1, 2, 3, 4, 5, up to k, since our set is going to be ordered.
Yeah.
Yeah, I think that's it. Uh,
Yeah, which I called it current. Like I'm simply gonna call it current, and every time I'm gonna increment it by one.
okay.
Uh,
Okay.
so I'm gonna return s, and I'm going to call it by one. Yeah, same idea. Like
Yeah, 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 yeah. Yeah, it's the same idea. Uh,
so, I think the pop is good. I'm just having trouble with the add. So the add here and the add there. But how how is supposed to add?
to add, yeah. I think by adding, it means like we take out the the popped element. Like if it's, for example, if we would add two, if two exist in the popped elements, we would simply take it out of the popped element set.
We're not gonna add it. Is late code
No, no. Since if we take it out of the popped element set, it means like it is not popped from the like infinite set. It means like it exists in the infinite set.
Yeah. Okay. Okay. Oh,
Yeah.
hey, hello, Hassan. Hey, I saw your comment. Yeah, lead code is not enough actually to get job. You have to do project. So outside the stream, I do project, Actually, I have to present a project tomorrow, and I think in the upcoming video I will try to show you a bit about this project and code with you some project uh, besides lead code. Welcome stream, by the way. In the add back, we're not gonna push, we're gonna pop.
Uh, no, for the add back, we are going to simply take out the like the num from the popped elements.
But
If
no,
if you
but
add,
he's like he is giving you a num in the parameter.
yeah. We would like we would see if the if actually num
If
if it
the
exists in the popped elements, we would take it out. If it's not, it means that it exists in the infinite set. So we would simply do nothing
oh, so
because
okay,
it's not
so
there.
okay. So if num in self dot set, we're not gonna do nothing. We're just gonna continue.
Yeah.
If it's not, we're gonna push. Okay. So okay. So I'm gonna make else here.
Okay.
Uh, can I make pass? Okay. Still not the good one.
Yeah, single dots. I think there is a problem with my solution. For example, if you do well, if you pop one and two, like if you draw an up of smallest two times, you would have in the popped elements one and two. And if you add back, okay, and if you add back like well, it's not there, so we're gonna take it out. If you add back like two, you would have um,
Oh,
okay, it actually works.
so
Okay, yes.
yeah, so I think you're talking about the condition of pushing of adding.
Yeah, of adding.
So if the we said that we're gonna increment the a value which is the current. So if we add a number which is lower than current,
Yeah.
which is lower than
No,
current.
no, we didn't use like the current element.
Oh, so
Like,
we didn't use it. So what did you do?
look at my
Okay,
code.
okay, I'm gonna look to it. So if not popped element return one, return plus one. Okay, okay.
I have some dots. I need to try it.
Yeah, same thing. I'm also using if nums is not in self dot set, which is the popped element in
Yeah.
your code. So you're simply gonna push it.
Okay. Okay.
You're gonna
Do
push
you still have
nums.
you?
Num.
Uh,
But here I have the current, so.
if num
Mm, mhm,
itself.
mhm. And let me push. So the
Num
num,
itself.
so the num has to
Point.
be lower than the current.
Popped elements. How to remove the element from a set? You just simply do remove
Yeah, dot remove.
and num. Okay. Okay, and here put popped
So here now is has to be load. Correct. Oh, okay.
Okay, it does work for you. Good job, man. Good job.
Yeah,
That's right.
thank you. Yeah, just this condition. When you want to push a number, it has to be lower than the current.
Yeah, 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 yeah.
I think. I hope this
Right.
work. Okay, so unknown network. Please reload.
No, try it again. Try it again.
Okay. Uh,
Okay.
oh.
Wow, nice, man.
Oh yeah.
Yeah, actually,
It's
it's
good.
really good, isn't it?
Yeah, even the runtime
Okay, okay.
is good.
Okay, I see you, man. Okay, okay, okay.
You need
It's
to.
actually
Hey,
showing you that
you have helped me though.
I did nothing, man. You
No,
did all of it.
you have helped me.
You did all by yourself, man. Good job.
I think. Do you want me
Okay.
to like try your solution and I'm gonna send you
No,
mine.
actually, let me finish my solution.
Okay.
I'd like to explain what you did.
What? Try to explain it. Okay.
Yeah, yeah, yeah. Explain it. Explain it.
So we initialize the heap and the set and the current, which is initialized by one to prevent the idea of popping a empty heap. So okay, so this one, if the heap is not empty, simply gonna pop from it and remove it from the set, which is the number of the like the positive integer that you talked about.
Okay.
Uh, so and then we're gonna return uh, this number, which is the smallest one, and else we're simply gonna increment the current plus one if we didn't find anything.
Okay. 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 So you just return the like the smallest and increment like the top by two by
By
one.
one. No.
Okay. So and for the add, you check if the number is
It
uh
has to be smaller than the current.
yeah, yeah, yeah. Because if it was bigger than the current, it already exists, so we don't
Yeah,
need to try it. Okay.
and it hasn't to be in the set because it is already there. We don't have to push it.
Yeah, exactly.
So then we push it and we add it to the set.
That's smart.
Oh, thank you.
Yeah, GG.
Yeah, Gigi, it's teamwork, man. So I'm gonna send you my solution if you want. Uh,
Okay, okay. Yeah, yeah.
your solution is pretty much the same, yeah.
No, actually, it's not like it's not correct. Because let me finish it. Like here, I'm trying to use like to not use a heap because I think we don't need a heap actually.
Well,
I don't know
yeah,
why, but
yeah,
I
okay,
like to
but
not.
just the load code problem say it's categorized in the heap, like
Where?
لا, no, in the if you go to the lead code 75, you're gonna find this problem set is categorized under a heap.
It's in like a heap.
Yeah, yeah,
Okay. So we do need a heap. Okay,
yeah.
okay. Okay, so okay, let's not do something like stupid. Okay, so the top smallest, like we need to check if like if me yeah sorry for that he okay would like um are new culture maybe kill not maybe off me.
Let me just finish the stream while you are
Okay.
correcting your code. So to everyone, this was a really I think this was a really good stream. Thank you everyone. I think this is the end of stream. Thank you everyone for following. Thank you everyone for watching. Thank you everyone for the support. I really always read your comments, your messages. I'm really happy to connect with you and to interact with you. So this is day 32. We have been streaming for more than a month. Thank you everyone, and as usual, see you tomorrow. So I think tomorrow we're gonna work on the what is it? Okay, so I think tomorrow we're gonna work on the binary. Oh, the heap. Okay, we're gonna continue work on the heap, or we're gonna switch to the binary search. It's not a big deal. So thank you everyone. This is the end of stream. Thank you. Don't forget actually to follow us on the YouTube, on the other social media account. You have my LinkedIn. I'm happy. I'm always happy to connect with you. Thank you everyone, and see you tomorrow.